Good morning, students. Welcome back to digital electronic class. So this is our series of online classes we are conducting. So in today's class we are going to continue the same topic of your combinational logic circuit. In that we are going to discuss the full subtractor. So in today's class we are going to cover the concept of full subtractor. In the previous class we have discussed about the full adder, half adder and half subtractor. In today's class we are going to cover this concept called full subtractor. In that, what is the block diagram of it? If you want to draw the block diagram, this is the way we'll draw it. What is this input value we'll give for full subtractor? We'll give three inputs, A, B and C. So this is your combinational logic circuit, right? What is the output for these two? Output would be difference and borrow. So these are your output values. So we do have difference and borrow. So thing is that we need to write the truth table for it. So how do we write the truth table? We'll take how many inputs we required? We required three inputs, right? So we are mentioning A, B, C. These are our inputs. Next, what we need to write? We need to write the output value. So we can write the output. This is the truth table. So what is the input value? 0, 0, 0. This is the first combination. Second is 0, 0, 1, 0, 1, 0 and 0, 1, 1. Like this. 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1 and 1. So these are inputs. What is the output value? First is difference. Next is, after difference, next would be borrow. So we'll write these are our outputs value. First is difference, second is borrow. So now we need to write the output by taking the input combination into the consideration. So here we do have three values. These are nothing but your inputs value. So now write down the difference of this one. 0 minus 0, it's 0. 0 minus 0, 0. So difference is also 0. Borrow is also 0. Likewise, I can go for 0 minus 0. Again it is 0. So 0 minus 1. Can I do 0 minus 1 like this? No. I'll get minus 1. So minus 1 should not be there for difference. All values should be either 0 or either plus 1. That's the reason what I need to do. I need to borrow 1. When I'm borrowing 1, what I'll get? I'll get 1 minus 0. So what is 1 minus 0? That is nothing but 1. That means difference is also 1 and borrow is also 1. Next thing, 0 minus 1. Again we got here. So what we need to do? 0 minus 1 we can't do it. So we need to borrow 1. So when we borrow the 1, what will happen? This will be reverse. Instead of 0 minus 1 it will become 1 minus 0. So 1 minus 0 is 1. Right? So again 1 minus 0 it is what? 1. That means difference is also 1 and borrow is also 1. Likewise, we go for next part. Again we do have 0 minus 1. So 0 minus 1 is what? Minus 1. So we'll not write negative in digital logic. So what we'll write? We'll write 1 minus 0. So we'll get borrow 1 here. Right? So we got here reverse operation. It is nothing but 1 minus 0. It's 1 minus 0 is 1. Again that 1 into 1. 1 minus 1, 0. So that means, so if you subtract these two, it will get 0 only. So how do we continue with this? Why we are taking borrow? Always keep in your mind, whenever we are subtracting the digits from 0 minus 1, the borrow bits needs to be high. If you are doing anywhere 0 minus 1, for that particular thing it is high. See here, it is also 0 minus 1, 0 minus 1, 0 minus 1. In all these things, 0 minus 1 is there because initial bit we are having low. That's the reason we got borrow. Likewise, you can go for this one. 1 minus 0, it's 1. Again 1 minus 0, it's what? 1. So there is no borrow. That means 0. So this is this one, this one, this one, this one, next this one. Next thing, 1 minus 0, it is 1. Till here it is 1. Again 1 minus 0, it is 1. We are not borrowing because MSB bit is higher. For higher bit, we will not borrow anything. Likewise, 1 minus 0, it is what? Till here it is 1. Right? So again 1 minus 1, it is 0. So we are not borrowing it. Again it will be 0. So this 2 is a 1 series. Likewise, I can take for 1 minus 1. What is 1 minus 1? 0. Again 0 minus 0. Both are 0. This is the next combination. Similarly, now tell me 1 minus 1. What is 1 minus 1? 0. Again you're doing 0 minus 1. For 0 minus 1 what we'll do? We'll borrow 1. So we will borrow 1 here. The operation will be reversed. It will become 1 minus 0. It is also 1. So this is the way we got the output for difference and the output for borrow. So we obtain the difference and borrow, the same concept. The next criteria is to, by using the Kmap, we need to realize this particular function. Then by using the gate level designing, we will design its function. So these are the steps that we need to follow. First thing what we have done, we have drawn its block diagram by giving the inputs. So these are what actually, these are inputs values. So after giving inputs, we draw the block. Since it's a combination logic circuit, why we are saying combination logic circuit? By combining the inputs, we try to write the output for that particular function. So these are nothing but combination logic circuit, in which, since we are designing for full subtractor, this is for full subtractor. So for that, the output would be difference and borrow. So we wrote it. Then we mentioned inputs value ABC. Then we took the truth table. Next thing, we need to write its Kmap. So we will draw the Kmap for these two outputs. One is for difference, another is for borrow. So for this one, we'll get two outputs by using how many variables? By using 3 variables Kmap, we will design it. So by using these 3 variables, we will take. So inputs values are what actually? So inputs are A and BC. So these are our combinations. So first would be 0 and 1. Likewise 0, 0, 0, 1, 1, 1 and 1, 0. So now same thing, I need to mention those mean terms values. What I can write for this? Mean term M0, M1, M2, M3, M4, M5, M6 and M7. So I do have these number of inputs we do have. So we just want to write the output for first one, that is nothing but difference. For difference I need to write the output. So how do I write? When difference is high, I'll mention the mean terms in the boxes also. M0, M1, M3, M2. So this is the way we went for this part. So 0, 1, 2, 3. Next 4, 5, 6 and 7. So we wrote this thing. So now what is this? When you had difference is high, for mean term M1, M2, M4. So M1, M2 and M4. For this it is high for M7. So M1, M2, M4 and M7. So we got this once. So can I make 8 combination? What is a Kmap states that the preference is given for octa combination. If it is not there, then go for quad combination. If it is not there, then go for binary. If anything is not possible, then we go for unary. So unary means single ones. So these are what actually? These are nothing but unary. All are singles. There is no adjacent ones. So if it is there adjacent one, we can write the output. Since there is no adjacent ones is possible, so all are separated. So what is the output for difference? So difference is equals to, write all the values. What is the first value? A, B bar, C bar, because it's 0. So A, B bar, C bar. So what I'm taking? I'm taking A is 1, B and C are 0, 0. So I can write A plus A into B bar, C bar. This is the first one. Plus, what is the next combination I do have? A is there and B and C is there. Right? A is also 1, B is also 1 and C is also 1. That means ABC. Likewise, I can go for next combination of the bit. What is the bit I do have here? A is 0, B is 0 and C is 1. So 0 means complement. So A complement, B complement and C. Plus, next thing, this one. So again, A complement because it's 0, B is 1, C is 0. So what I'll write? I can write as A complement, B and C complement. This I got. Same thing, what I can take common A in first two. How we got the full adder? This is the same thing I can got for full subtractor. So what I'm doing? I'm taking A common. So what I got here? I got B complement, C complement plus, this is nothing but BC. Right? Plus. Now tell me what I'll get common in this. I can get A complement common. So I get A complement as it is. So I got B complement C plus BC complement. So I can write for this as nothing but what? exclusive NOR. This is for exclusive OR. By writing this thing, what I can write for the first one, I can write for exclusive NOR. For second one, I can write for exclusive OR. So by writing exclusive NOR, exclusive OR, I can find out the value for that particular mean term. So in that first output I wrote for difference. Next I'll try to write for borrow. So I'll write the combination of this thing. So I can write here, I can take A common. This is nothing but B exclusive NOR with C plus A complement B exclusive OR with C. This is the output for difference. So this whole is your actual output. So we found for difference. Next thing what we need to find? We need to find for borrow. So now let's see the borrow. How do we find the borrow? So next what we are taking? We are again taking the same 3 variable Kmap. We'll take the input combination. This is A, B, C. 1, 2, 3. This become 4 columns and 1, 2 rows. So this is the combination for A can be 0 or A can be 1. Since we do have BC, so BC means 0, 0, 0, 1, 1, 1 and 1, 0. So we wrote for B and we wrote for C. So what is the first box indicate? It's nothing but int M0, M1, M2, M3, M4, M5, M6 and M7. So next thing, writing the output. So when borrow is high, 1, 2, 3 and 7. For these all values, borrow is high. So 1, then for 2, next for 3, next for 7. So we got here C students. So we got for M1, mean term M1, mean term M2, mean term M3, mean term M7. For these values, your borrow bit is high. For doing this thing, what I'll do it? I'll try to combine. What I need to combine? First 8 combination. Is it possible to combine 8? Do we had 8? No. Try to go for 4. Can I make 4 combination? If here 1 is there, then I can combine these all 4s. So I don't have that also. So what I'll do it? I can combine 4. Either I can combine 8 or I can combine 2. I cannot combine 3. Don't make a combination of these 3 is 1. No. Possibility of making octa combination or quad combination or binary combination. If all these is not possible, then single unary combination is possible. That is only the rule to do with Kmap map or Kmap. That's the reason we are proceeding this thing by using 2 to 1 combination. So I can combine these 2 ones. Next I can combine this again 3 with M2, mean term M2. Again I can combine M7 with mean term M3. Means M3 is coming in all. We can take like that. There is no like once we take M3 in the first combination, second combination we can't take it. We can take it. But the thing is, it should cover some mean term. It's covering this mean term, right? That's the reason I'm combining it. Clear? So what is the thing we need to keep in your mind while you are taking the combination? First preference is try to give for octa. If you do have 8 adjacent ones, if adjacent ones 8s are there, then we'll combine it. If it is not there, then we'll move to 4 8 ones. 4 ones are there in the adjacent cells. If it is there, then we will do it. If it is not there, then what we'll do it? We'll go for 2 combinations. That's the reason we are combining 2. In that, M3s keep on repeating. Don't look into M3. M3 is what? It is using to make the combination with M1. It is used to make the possibility of making binary with M2 and the possibility of making the binary with M7. Because of that particular thing, we are taking M3 multiple times. So now first thing, I am taking this combination. What is that combination? Between M1 and M3. So between M1 and M3. First I'll write the combination. Next I will take the combination between M2 and M3. Then between M7 and M3. Then can I get the output for borrow. By combining all, I'll get the output for borrow. Now tell me between M1 and M3 what is common? A is common. So it's A complement. In this 2 you just look into the column wise. So C is 1 here, C is 1 here. So I can take A complement C. Clear? That is the first binary combination. Next binary combination is M2 and M3. In M2 and M3 again it is coming under the same row. So it's nothing but A complement. Likewise here what is there? B is 1 and 1. So I can write A complement B. Next thing M3 and M7. Row, see the row. A is 0, A is 1. So A is changing. So we will not write A. What we'll write then? We will write this one. Vertical way we are saying only this is there. That is nothing but B, C. So what is the output we got now for borrow? A complement C plus A complement B plus BC. So that is the output for borrow. So we got the output for borrow. So we got the difference and then we got the borrow. So difference and borrow is quite different with carry. As you compare this bit with carry, in carry what is there? Here we do have AB. Complement is not there. AB plus BC plus CA is there in what? In carry. Whereas in borrow what is there? It is there A complement C, A complement B plus BC. This is the way you can compare it and you can just cross check whether you are doing proper or not. That is a method to just verify whether the points whatever you are taking, is it you are taking in that proper sequence or not. Clearly? So next thing what we can go for it like this. This is quite similar to your sum. But here variables are quite different. So in that one we just took the numbers. Same way here also the same thing is there. Combination is also same. So but you need to remember this thing, borrow and difference, that will be useful for designing. You can take two half subtractor, you can design one full subtractor. That is also one of the method we can do it. Likewise, we can take two half adder, we can combine and we can make one full adder. So that is also we can do it. So now till now what we have done, we have taken three input students A, B, C. We wrote the output for difference and then we wrote the output for borrow. So in difference, when difference is high, when you have one bit is low, one bit is high. So what is the logic of this? So difference when it is high. So when you had anything, one is low, another is high, then only difference is 1. When borrow bit should be high. So when you want to write the borrow bit, when you have 0, when you are subtracting from it, then it will be high. So that's what, whenever we are doing 0 minus 1, for that particular situation only you got the borrow bit. As you can see here, 0 minus 1. Borrow bit is high. Similarly here, you are doing 0 minus 1, 0 minus 1. So for this particular situation, compulsorily you need to get the borrow. For remaining, all are high. High bit only starting. But in this situation, what we got? 1 minus 1, difference is 0. So we got 0 till here. Then again for 0 minus 1. So again 0 minus 1, your borrow bit needs to be there. That's the reason you got this particular borrow bit. So this is the way you can proceed with your full subtractor. Now let us see the designing part of it. How do we design the full subtractor? By considering its mean term. So what we got, students? So we got difference and we got the borrow. So what we are doing? We are taking difference value. So difference is equals to, what is the difference value we do have? We have it as A, B, X NOR with C plus, next we do have A complement, B exclusive OR with C. So this is your difference. Likewise I can write for borrow. So what is borrow? So borrow I do have A complement C plus A complement B plus BC. So I do have these two. So I am writing borrow and I am writing difference. Next thing, I need to write its value for it. So how do I write the value? By taking the gate level design. So by using the gate level, so designing, I'll take the same ABC, I'll take it and I'll try to write the output. So either you can go with horizontal approach or you can go with vertical approach. So I'm going with vertical approach. So I'm taking A and the complement of it is one NOT gate. Then B with one NOT gate. Then C with one NOT gate. So I got ABC. These three values I took. Now first thing I'll solve these brackets. So B X NOR with C. I can put B XNOR with C. That is the first thing. Second, XNOR. XNOR means there should be a bubble here. Next, B exclusive OR with C. So this is the thing about B exclusive OR with C, B XNOR with C. So we wrote it. Next thing, I need to multiply with A. So for that, what I'm doing, first I'll connect this thing B and C. This is your B, this is your C. Similarly here also, B and C. First is multiply with A. So I'll take the input from A, I'll connect with one AND gate. Likewise I can take for the second one A complement and connect with one AND gate. After that I need to add. For adding, what I'll do it, I'll connect with one OR gate. This is the way I can do it. Or else without doing this thing I can go with A B bar C bar plus A B C plus A complement B bar C plus A complement B C bar. This is there, right? By using the basic gates you can design by taking these 4 terms. That also you can do it. You can connect 4 AND gate and one OR gate by giving the combination. That is what basic gates. I am taking special gates also so that you can be familiar with special gates also. Because of that reason I am using this exclusive OR and exclusive NOR. Because we know exclusive NOR is what actually? B complement C complement plus BC. Exclusive OR is what actually? B complement C plus BC complement. So because of this thing, instead of using this one, I have just taken this particular part. So we got till now what is the output this thing? This is nothing but the output for sum. Next thing, what is left out? We have to go for carry also. So carry, how many? 1, 2, 3. 3 AND gate is required. So I'll connect 1, 2 and 3. 3 AND gate. And for adding this thing, what I required? I required one OR gate. So I'm connecting with one OR gate. So this is the output for carry. Not carry, it's what? Difference. Difference and borrow. Since we are doing full subtractor, this is the output for difference, this is the output for borrow. So what is the first combination? A complement with C. So this is your A complement, B complement and C complement. So A complement with C. This is A complement with C. Second, A complement with B. A complement with B. A complement with B. Next, BC. So we need to take the B input. This is our B. And then C. So this is our C. So this is the way you can use it, the gates level analysis of your difference and borrow. So students, so till now we have discussed about the difference and borrow and then sum and carry for full adder and full subtractor. In the next class, we will continue the same concept of combination logic circuitry designing. In that, what is the thing we need to discuss? We will discuss more details about this. We'll be having carry look ahead adder, carry save adder. This thing is there. And then we do have how do we design the full adder by using 2 half adders. That also we will see in the next class. With the help with this also we do have one more concept of multiplexer, demultiplexer, encoder, decoder. Those things also we will cover in the upcoming classes. Thank you for today's class. Just make a note of it, all the points what we have covered. As soon as the college will open, we will check the notes also. So just maintain your notes and the problems which we are giving, all those things you need to maintain a separate notes for DE subject. If you do have any queries, you can put your queries. I'll give the mail ID in the description of the video. So you can ask your questions and doubts about these topics.